What exactly is information? Well, what is info? That's a good question. Well, it depends on the context in which you're asking me. Are you asking me about information from the context of information theory, or from the perspective of quantum theory, from the perspective of black holes, from the perspective of computer science? So, if you're talking about computer science, then information is just bits and bytes, ones and zeros, right? Like we discussed some time ago, ones and zeros stored on the computer's hard drive or in memory or in RAM or whatever. That is information from the perspective of computer science. From the perspective of quantum physics, information is the various states of of the system. So let's say you have a system. Let's say you've got a square box in which you have a gas. Okay, let's say you have hydrogen and helium mixed together, and let's say you have n number of hydrogen atoms and m number of helium atoms. Okay, and it's a mixed gas and they are interacting in some way or the other. So in this case, information is the state of each of these atoms or molecules. Okay, the quantum states. Let's take atom one of hydrogen. What quantum state is it in? Is it in the ground state? Is it in the excited state? So all of these various data points taken together is quantum information. Are certain atoms entangled? Are there superpositions of some kind, and so on and so forth? All of that is quantum information. In information theory, information is correlated with entropy. I'll not go into that. It's pretty complex. I don't know how to explain without mathematics and so on. From the perspective of black hole physics, information is again the quantum states of everything that goes into the black hole. So a black hole is a classical object. Okay, a black hole is, from the perspective of general relativity, it's a classical object. It is a very simple object from the perspective of general relativity. It has only three properties: mass, charge, and angular momentum, and that's it, nothing else. So it has a certain amount of mass, it may or may not have a certain amount of charge, and it may be spinning or rotating or not. So mass, charge, and angular momentum, and all the properties of a black hole can be described by using these three parameters. These three parameters. And other properties are derivatives of these three parameters. For example, entropy is a function of the surface area of the event horizon of the black hole. Uh, the radius of the event horizon, if it's a Schwarzschild radius, then it is 2 mg by c squared, and so on. I'll not go into the details. So a black hole, from the general relativity perspective, is a very simple, straightforward object. But it is, let's say, it is a black hole that is accreting gas. So it's accreting hydrogen and helium and whatnot gas. I mean, all of these gas atoms and molecules are quantum objects, and they all have quantum information within them. It's also, uh, once light crosses the event horizon, even light is not cannot escape the black hole. Light also has information, polarization, in what direction are the electric and magnetic fields pointing, polarization information. So all of this quantum information is going into the black hole. It's going inside, right? Now, once it goes inside, what happens to the information? Does it get destroyed? Does it get scrambled? And all that is the black hole information paradox. Because black holes have temperature and they radiate the radiation, Hawking radiation, which could be particles, antiparticles. So it has a black body spectrum, and these particles that are emitted, do they encode the information that went in, and so on. So that is the black hole information paradox. If you want to answer what is information, you have to understand from which context, from which perspective you want to understand. Computer science, black hole physics, quantum mechanics, philosophy, whatever. So there are lots of different ways of explaining what information is. Also, information theory.